Hi everyone, in this video I'm going to show you a way to create this kind of reconstruction effect in thinkingParticles. So I have my 3ds Max scene here, and I will start by creating a new thinkingParticle system. Okay. I will create a sub group and a sub dynamics for my setup. I'm gonna call it Reconstruction. Alright, and so I will need to import this object in thinkingParticles. So here I'm gonna create a new dynamic set with an object to particle operator, and I'm gonna pick this object, instance shape. I can hide the full layer instead of using the hide button here, and I'm gonna create a group called input object. And in the object to particle operator, you can send this object to the input object group. So this way, you can see I have my object imported in thinkingParticles. So after that, I will use a fragment operator to split this mesh. Okay, so I can create a new dynamic set and a new group to store all the fragments. Right, and in the fragment dynamic set, I'm gonna use a fragment operator on the input object particle. So at first, as you can see, it's doing nothing because the threshold here is set to 1. So quickly, this fragment op will allow you to split the mesh based on some parameters here and properties, and by default the threshold is set to 1, so it has no effects. You can use a map here, black and white map, to decide where you want to split the faces. Okay, but if you set the threshold to 0.5, you will see, let me just send the particles to the frags group, so you will see it will split half of the mesh, and if you set the threshold to 0 with no map, it will split just all the mesh. Okay, so let's set it to 0.5 for the tests. Okay, so here in the fragment group you can choose between different modes or conditions to have different kind of splitting. Like by default it's smooth and distance, but for this effect you can just use the count mode, where you just specify the number of fragments you need. Like by default it's 5, so as you can see I shall have 5 red particles here, and if I set it to 500, you can see you have 500 fragments. Okay, you can set the lifespan very long because we don't want the fragments to die. And here by default you can see TP is performing some kind of extrude here to add thickness to the fragments, and it can be interesting if you want to try, but you will have a very high poly count, so I prefer to set the thickness to 0 for both remaining shape and fragments, so this way I don't have any thickness. Okay, no extrude. So as you can see, it's pretty cool, it's pretty fast, but for this effect we will need lots of polygons to avoid this really you know, straight edges look. So I will need to just hide my TP for a moment and add some turbo smooth on my object, and maybe with 2 iterations, you know. If you have a clean topology like this one, turbo smooth will do the trick, but if you have something like a CAD model or something with a lot of triangles, you can also use the subdivide modifier. So okay, subdivide, here you are, and It's pretty cool because it will just create even sized faces, as you can see. So for this effect, it can be pretty cool to use to divide, because you will have faces of the same area. Okay, so now you can display TP again. As you can see, it's still walking, but because we have more faces, we have a less straight look on the fragments. And of course you can, in the fragment op, you can set the count to a really high value, like 5,000, and this way you'll have a lot of fragments, as you can see. Okay, so for this effect you will need the fragmentation to append over time. So we can use an animated frag mask here. So to do it, I will just hide the TP for a moment and create some new UVs on my object, and make sure you don't override the texturing channel. So I can use the map channel 2. I know it's a free map channel, okay? And you can, for example, find some good point of view and hit view align. So your UVs will be based on this view, and as you can see, if you create an unwrap UV node for the map channel 2, you can see now I have this UV layout on the map channel 2. So what you can do, you can open the material editor and create some standard material and use a gradient ramp, and you can assign this material to the object, okay, and make sure the gradient ramp is using the map channel 2. So now you should be able to just see, okay, you can rotate it like that. So for testing, I will use an animated gradient, but keep in mind, if you want more control, and we will do it later, you can just export this layout to Nuke or After Effects and really animate some mask to really design the reconstruction. Okay, but for testing, I'm just gonna use some animated gradient for now. So, okay, I will just animate it like with the auto key mode. I can something like that, and at frame 60, for example, I want it to be full white. Alright, so as you can see now, I have this animated map, and I can use it in TP to drive the fragmentation. So in thinkingParticles here, okay, so now I'm just gonna reapply the gray material to see something cool in my viewport. So okay, in TP, in the fragment op, you can just use this black and white animated gradient as a frag mask. So let's do it. Alright, so okay, as instance, of course, and here, since you have a map, the threshold defines where the mesh should be splitted according to the black or white value. So if you set this threshold to 0.5, if the map value is greater than 0.5, the mesh will split. Okay, so since we use a pretty contrasted map, it doesn't really matter. It can be 0.6, 0.5. It will do the trick. So now, if I just hit play, as you can see, yeah, the fragmentation is happening over time. So this way, it can be pretty cool as a destruction effect, you know. But since we wanna do reconstruction, we will have some more complex work to do. So first we can hide the remaining shape, so we can set the type to known. So this way, okay, we don't have remaining shape but only the fragments. And you can see the fragment operator as a speed parameter here, so that's why our fragments have some initial speed based on their normal, I guess, but you can set it to 0 so you don't have any speed. Alright, and you can here in the master dynamics make sure this force setting about the display type is off, so you will be able to choose different display settings for each group. So I don't want to display ticks or dots for, I just want the mesh, for example. And okay, so now we have the base of our reconstruction setup. So as I said before, instead of using this gradient, animated gradient, if you want more control, you can just render the this UV template here. So you go to Tool, Render UV Template, and you can save it to your hard drive. And then you can use software like Nuke or After Effects. I just did it quickly. To import your object, you create some roto node, or in After Effects you create some solid and a mask, and this way you can animate, and you will have more control than using a gradient ramp. Okay, so then you can just render it. All right. And back in 3ds Max you can just use Bitmap to import this sequence. Okay, perfect. And use it instead of the gradient ramp, and make sure here it's set to use the map channel 2. And now it should work. Oh, sorry, I need to assign it. And now, okay, you can see now we are seeing the mask I've done in Nuke, and it's cool because you can really control the shape you have here. You can add a bit of noise. It's really nice, and it's not that slow to set up. And if you have multiple objects, what's cool is that you can do all the mask, and you have a nice preview in the viewport of the reconstruction. Okay, so in TP I can just change the mask here, and now I want to use the bitmap instead of the gradient, and it should work. Alright, so let me just, as before, reassign this grain material to the object. Okay, so we have done the first part of the setup, and now we will need to do some extra work on the animation of the frags, because for now, as you can see, the frags are just popping in place, and we want something like this with some cool animation on the frags. And as you can see here, they are just like coming from a different position, different size and different orientation, and going to their final position. So to do this, we will need to use a memory node in TP, and I will try to explain it if you're not familiar with memory nodes. So okay, so first I will need to create a memory node, and most of the time when I use memory, I create a memory node at the root of my setup and call it memory master and the name of the setup. So this way, in this memory, I can define some variables. And if you don't know the memory node, basically it's just like you can create variables here, and it's actually a solution for you if you wanna store data for a particle and use it later in the setup, in the graph. in a different dynamic set, you can use the memory for that. So I create a memory node at the root of the setup to define the variables. So the idea here is like we will create a memory channel to store the size, for example, of the particle at birth, and then we will modify the size and interpolate between the modified size and the original size to do the animation. Okay, so I can create a new size channel called rest size, and another one called mode size. So for each fragment, I can actually do it here, because after the fragment, this output will be only valid at birth, but you can also do another dynamic set and name it set rests. And here you can say for each frags particle at birth, so I can use a particleAge, and so it will be only active at birth. For each frags, I'm gonna store the size value in the rest size channel here. Okay, and then in another dynamic set that I can name mod pdata, I can modify the size. So for each frags at birth, I can use the size operator to modify the size. For the example, I can set it to 0.1 centimeters. So now, if I hit play, you can see all the particles have a size of 0.1 centimeters, but they still have their original size information in the rest size memory channel. Oops, I need to do this one. No, they have it. Sorry. So, okay, each particle has a size of 0.1 centimeter, but they still have their original size information in the rest size channel here. So then the idea is to interpolate between the modified size and the original one over time. So to do this, I will just need to store the modified size in memory. So I can just copy this setup here and paste it here, and instead of setting the rest size here, I can just set the mod size. Alright, so to explain again what I did, so for each frags, okay, at birth, I'm storing the original size in the rest size channel, then I'm modifying the size, so I can set it to 0.1 for example. So it's really small, or I can even set it to 0, so it's invisible, but you can still display as text. So okay, so then I store the rest size, I modify the size, so I set it to 0, and then I store the new size value, so in this case it's 0, in another memory channel called mod size. So I have the original size in the rest size and the new size in the mod size. And then in the new dynamic set, I will be able to interpolate between these two values to produce this animation. So at birth is 0, and over X frames it goes back to the original value. So there are different ways to do this kind of thing, but one I really like is use the egg timer node. It will allow you to set up a timer of X frames here, and so I connect the particle here to the X timer, and I need to plug a boolean here to say, okay, when I want the timer to start. So I can use a particleAge and say for each frags, when the particle born, I want to start a new timer of like 20 frames. Okay. And what's cool with egg timer is that you have this time relative output, which will output the local age of this timer between 0 and 1. So at frame 0 it would be 0, and at frame 20 it will be 1. So we'll use this one because it's really nice to use to do the interpolation. And so what I can do is I can use a memory node to just get my rest size and my mod size, and then I can use a particle data to set the new size. Okay. So just to make everything clear, as you can see, if I set the rest size here to the size, you can see we'll have the original size, and if I set the mod size, which is 0, we'll have the size of 0. So to do the interpolation, we'll use an expression node, and we will need to set up a pretty basic expression. So actually, as I say, when the timer starts, the time relative is 0, and when it ends after 20 frames, it will be 1. So what I can do is I can just multiply the rest size by the time relative, and the mod size by 1 minus time relative. So okay, so to set up this, this is a scalar, and we have some scalars here, and we want to output a scalar. So I can add some scalar output. So S1, S2, and add a new output scalar, S3. Okay, and so S1 will be the rest size, S2 will be the mod size, and I will create another scalar input that I can call bias to plug the time relative in. And so this one I can rename it to interpolate expression. So here you want, as I said, so rest size, so S1 times bias plus S2 times 1 minus bias. And this way, as you can see, it should work. Yes, we have a nice interpolation over 20 frames here. To control the duration of the animation, you can just change the frames here in the timer. So if I say 5 frames, you will see it will be really faster. So maybe 8 can be cool. And you can also use a value-to-value node here to have something less linear. Back in the time we have to use value to time, but now in TP6 you have value to value, and you can, and it's really cool because it will allow you to remap the time relative output to something less linear. So if I plug it here, is this bias, you can see with this linear curve it will be the exact same result. But you can modify it, for example, to have something a bit less linear. So if I switch to Bezier smooth, I can actually do it this way. For example, you can have something really. Let me test this one. If I do something like that. So the size will be pretty small, and then it will be faster switch in this area, and then smaller to get the last final size. So if you just preview, you can see, yes. So it's really less linear. So it's really nice because this value to value will allow you to have a better control over the interpolation. Like if I set a slow curve like that, you will see it will be like really fast at first, and then the size change will be slower to the final size, like that. Now it really depends of what you want, but in this case I can stay with something pretty linear and maybe just make it a bit like that. Alright, and instead of using a frame value inside the egg timer properties here, you can expose it, and you can do a random per particle, and make sure you are in the random for each particle for the whole animation between 7 and 10, for example. And this way, instead of using this fixed number of 8 for each particle, it will use a random between 7 and 10, so it will add a bit of extra randomness to the effect. Okay, so it's working for the size, and basically we will need to do the same thing for the position and alignment, and basically it will be the same thing, but instead of scalar here we will deal with vectors. So I can make a bit of room here. Okay, and I will just repeat the same process. So I will define for the alignment, for example, I will create a new alignment variable called rest align, another one called mode align, and after the fragment here I'm gonna store the original alignment. Oops, sorry. I'm gonna store the original alignment in the rest align channel, and then here I can modify my alignment, so I can just use an alignment node and use some random here alignment. So now, as you can see, the frags have a random alignment, and then I will store this alignment in the mode align channel. Alright, and then here I will just duplicate the value to value, so I can use a different curve for the alignment, and instead of scalars here I will need to use vectors, so I can remove the inputs and add vector ones instead. So v1, v2, and add vector output, v3, connect the value to the bias, and here I can get the rest align and the mode align. So rest align will be v1, mode align will be v2, and I will need to modify the expression, so it's not s1, it's v1 and v2. And here it's a bit tricky, but in TP the alignment here, it's not a vector, it's some kind of alignment matrix. So if I try to connect it this way, it will not work. But what you can do here, actually TP is converting the alignment to vectors direction on the fly, and so if you use an alignment node and you plug this vector in the direction, it should work. Just here make sure you choose user define, and I think we will need to change it to the X. Yes, you can see it's working, but particle axis should be set to X value. So yeah, and now as you can see it's working. And as before, you can modify this curve here in the value to value to maybe we want some faster curve for the alignment. It's up to you, but yeah, let's try this one. And yes, basically we're done with the alignment. Okay, maybe switch back to some slower curve. And now we're gonna do the same thing for the position channel. So as before, here in the memory master I create some position channel, where you are here, rest position, rest pause, and I create a new one called mod pose. In the set rest here, I can set the rest position to the position value, and here I need to modify the position. So I can use particle data, and this one will be a bit more complex, because I can't just use a random or a zero value, but I will need to just displace a bit of position, and for that I'm going to use a 3D noise. So I think Joskar did a tutorial about 3D noise in TP, so I think I'm going to do the same kind of things, maybe less complex, but just I'm gonna just set up 3D noise to just displace a bit the particle position. So to do this, I'm gonna work on a sub-dynamic set to keep things clear and organized. So okay, in the set mode, mod p data, I'm gonna create a new dynamic set and call it 3D noise. And so here I have my 3D noise here. So to do a 3D noise in TP, you can use textures, noise textures, and sample them in TP to do the noise. So okay, so just get some noise texture, and I will duplicate it 2 times to have a XYZ. And what you can do is just so use a text map color, and this node will allow you to sample a texture in TP based on some UV points for each particle, UV coordinates, or surface position. If you're using a 3D texture like a noise, you can use the UVs with the explicit map channel, or the objects XYZ, that will be the world position in object space. So you don't even need UVs, you can just use the position. So for this, you need the surface position input to be connected. So I will connect it to the position here of the frags. And so for each frag, I will sample a noise texture. So here in the text map, you can just add the noise. And so for XYZ, I will just need to set up some offset to have different values in for XYZ. And so I will duplicate my text map color. Sorry. So this will be X, Y, and Z. And so in the second one, you can connect the Y noise, and on this one the Z noise. Perfect. So I have these 3 text map colors, and I can get the color. So since I don't want to deal with RGB data here, but I can use a color helper to just convert it to some value. So to get the value as a scalar and not the color. So okay, I can get the value, do this for the 3 channels. And then the only thing you need to do is create a point tree and say, okay, this will be the X value, this will be the Y value, this will be the Z value, and okay, then this will output the vector. So basically, areas are the base of our 3D noise. So as you can see, if to modify the position, what I can do is that I can just add it using an expression or maybe a math node, and I can say, okay, vector and vector, and I can add the noise to the actual position and just see what I have. And oops, sorry, wanted to happen only at birth, of course, because it was adding the noise on each frame, so now it will add it only at birth. And as you can see, it's kind of working with it. It's really small. So what you can do is here you can use multiply and modify these values, but what you can do if you want something more organized is that you can add some float and connect it here as another input, and you can rename that to something like intensity, and here you can use a math node, and in this math node say using vector and float, and say I want to multiply this vector by this value and output here at the vector. And so this way here you can create a float and control the intensity. So if I say 10 for example, you can see it will be a bit bigger, so maybe I will need to deal with really bigger values. And so yes, but it seems like it's offsetting the whole thing. So okay, let's just disable it for a moment. Yes, and that is because the noise is really too big. So you can change the noise size here in the material editor, like say the size to 1 for example. Maybe it will be a bit better. So it was so big that it was displacing the whole thing. So now let's see what we have. Okay, it's working a bit better, but yeah, you can see now it's too intense. So let's reduce the intensity to 1, and okay, now we have it. So you can tweak the intensity, and actually what you can do instead of modifying the size of the noise here, what you can do is you can actually act on the surface position. Like if I add a point 3 here and connect the surface position to it, and then I can use another math node to say with a float and a vector, sorry, it's vector and float, and say multiplication, connect the float here, and you can rename that to let's say size. And instead of plugging the row surface position, I would plug this one in the text map colors. So I will need a 0.3. No, it's okay, sorry. So you can plug this new vector as a position. So instead of using the surface position, I use the surface position multiplied by a scalar. And so this way, instead of modifying the size here for each map, you can just, if I set it to something like 0.5, you can see the noise should be 2 times smaller, or 2 times bigger, sorry, multiplied by 2. Okay, 2 times smaller. So in my opinion, it's better to use this one because it's not really user-friendly to modify just 3 values on the material editor. Or as Josko said in this tutorial, if I remember, you can use a parent block to modify the noise properties, but for the purpose of this effect, you can just use a multiplier on the surface position to deal with the size of the noise and the intensity. So and so last thing you can do, if you look at the noise here, it's actually going from black to white, so 0 to 1, and in this setup it can be cool to have it from -1 to 1. So what you can do to do this is use value to value here, to remap this noise, it's going from 0 to 1, and you can see the output from -1 to 1, so this way you will have negative values for each axis. That can be cool because it will add even more randomness to the effect. So this value to values node allow you to remap the noise that is 0 to 1 in the texture to something that goes from -1 to 1, so you can have positive and negative offsets for each axis. So as you can see, it's looking really cool. So okay, we have modified the position using a 3D noise, and so I really recommend to store this thing as a black box. So next time you will need to do some kind of 3D noise, you will not have to recreate this whole setup. Okay, and same thing as before. Here you can set the modified pose to the memory, and okay, just let me rename these dynamics to animate frags, and here you can get the rest pose and the mod pose in this memory, and just copy this interpolation expression. Since we're working with vectors, it should be the same as alignment, so you can create another value to value to have a different control for the position, and so rest pose, mod pose, the bias, and here in the particle data you can say okay, set the position, and it should work. Alright, so as you can see, it's working. We have alignment, position, and size interpolation. If you want to have control over the duration of the interpolation and the animation here, you can just change the random here, like I say, a random between 12 and 22. You will see it will be a bit slower to reconstruct the object, and you can still control the numbers of fragments you want here in the fragment op. Like if I say 100, for example, I will have few but bigger fragments. That can also be cool for certain kind of effects. And you can also have like 10,000 frags. It will be a bit slower, but it's still pretty fast to simulate. And keep in mind that 3ds Max display is really slow, but actually if you change the display mode to ticks, it should be a bit faster than mesh. So if you're working on a really big effect, sometimes working with ticks display can be really helpful. Okay, so switch back to mesh. And so then, when you're happy with the result, you can just cache it using ThinkBox Xmesh if you have, or just doing some TP cache here. And as you can see, it's pretty fast to simulate. So okay, I've cached my TP, so now I can scrub the timeline, and as you can see, it's quite fast. And I'm not going to cover the shading I did in this example, so I will just tell you basically how I did. You can do it in TP using the material time operator and animate the material, but you will have only difference for each frags, and in this case actually it's easier to use the gradient you have done here. For example, you can if I create standard material, so you can use it as diffuse color and display the material. So if you change the material on TP that is cached, you can save material here, so it will override the material on the cache. And what you can simply do is, like in the time, you add an offset of like 20 frames. So as you can see, it's really doing the trick. Make sure it's hold here, the end condition. So yes, now as you can see, using a simple offset will do the trick, and you can also increase the blur value here. So you can view it in the viewport, but at the time you will have a lot more blur in the map. And basically what I did in this example is just like I used a V-Ray blend and this map to a mix between an incandescent material and the metallic shader. So yes, it's pretty easy, just using the gradients to drive the shader. Okay, and last thing I want to show you is that, okay, I worked on this mesh, and to prove you that the setup is pretty procedural, what you can do is like just remove the cache in TP. And if you want to apply it to another object, so I just did some animated gradient for this one. Okay, so the only thing you will need to do is like, okay, make sure you have the turbo smooth applied to the object. Okay, and what you can do then in TP, you just need to in the object to particle, you pick the new object, send it to the input object, instance shape, and in the fragments you will need to change the mask. So I can use the new gradient hidden here, add instance, and it should work fine for this new object. So as you can see, it's working. Alright, and last thing, if you want to optimize the setup, you can just here in the animate frag, thing is that it's still computing the interpolation for all the fragments, so it's pretty fast. But if you have a really huge number of fragments, it can be quite slow. So what you can do is that you can add a static group, and let's put some gray color and display as mesh. And so after the egg timer, here in the egg timer you can see you have a rich output, which is a boolean. So basically when this is running, the rich value will be 0, and when the time relative is 1, so it have down all the frames, the rich value will be 1. So what you can do is just use a group. You can use a group here and send the frags particle to a new the new static group when time is reached. Okay, and so now you should be able to see that once the particles have reached their original position and alignment size, everything, they switch groups, and so you don't have too many frags in the red group, and you are not performing the interpolation on this frag, on all the gray frags. So it will optimize your setup.